this is, like I said, this is really going to just piggyback on what we did yesterday, so it's similar, but I'm actually going to have us graph in the coordinate plane a little bit. My first question, I've got a rectangle pictured here, and it says we're going to make two similar rectangles. The smaller rectangle is given, and one of the sides of the larger rectangle is given, but it says we want to finish drawing it. Okay, and I don't have this twisted or anything. They're oriented the same way. All right, so this little segment right here is supposed to be one of the sides in, excuse me, the larger rectangle. So we're going to finish drawing this. Okay, so first thing I would tell you to do, the rectangle we already got drawn in there, right? I just have straight horizontal and vertical lines, so we can find the lengths of the sides here, and then we can compare them. All right, so if I look at the little bitty triangle that's already graphed here, it looks like the top and bottom, the side lengths, again, I could just count. I don't have to do like a Pythagorean theorem or a distance formula, because anytime we have a horizontal or vertical line, we could just count. So top and bottom there look like they're 3, and left and right looks like they're 6.
It looks like similar. So I was saying that the bottom one looks like a side, like a, that's the, like,
So that's going to be one of the sides of our larger rectangle.
Probably going to be a similar ratio.
You're totally right. Did you just guess that, or did you figure it out?
That is one of the short sides.
Gotcha. It is one of the short sides. Okay, so if this is 3, you guys can count this segment here. This is 6. All right, so those two sides would correspond to each other. So I could just write from there, right? This question asked me for similarity ratio. So 3 over 6, I'd want to make sure we would reduce that before I would write it on the line. So 3 over 6, larger to smaller, reduces to 1/2. Okay, now I can also find the left side and the right side of the smaller rectangle here just from the picture. Can anybody tell me, like, how would you complete the sides of this rectangle? Like, what would the lengths of the sides be in the bigger rectangle that I don't have, like the left side and the right side? Anybody know what they would be?
I think it might have.
It would be the nice number. How did you get 12? Exactly. Okay, so 3 to 6. It's a 1/2 or a 2 to 1. You can flip the fraction over. I just had to do smaller to larger. But if this is 3 and this is 6, you're just going to double. So this side is 6. You're just going to double that from the smaller one. So it'd be 12. So I'm just going to draw two sides just from the ends of that. So I'm at -6. So to get a distance of 12, we'd have to go up to +6. So I'm just using my highlighter here. So same thing, I'm just going from -6, and I'd have to go up to +6. That would give me a distance of 12. And then I can just cap the rectangle off. This across the top should match it with a 6. And just to kind of prove what we were talking about yesterday, we got to make sure that our perimeter ratio here, make sure we drew this correct, is our perimeter and our area ratio correct. So just really quickly, perimeter of the smaller one, we just add up the 4 sides, right? 3, 6, 3, 6. What would that give me? 18 if I add up the sides. Now, bigger rectangle, these two sides are both 6, these two sides are both 12. So if we add those up, I'm going to get 24, 36, thank you. And, okay, now, the perimeter ratio should be a 1/2. It should be the same. So if I put the smaller to larger together, 18 over 36, if you reduce that, that is also 1/2. So I definitely know I did that correctly because those are the same. Okay, now area, we did mostly triangles so far. These guys are rectangles. So area of a rectangle is just length times width, or some people think of that as base times height, whichever is the same for each. So for the smaller rectangle, one of the sides is 6 and one of the sides is 3. So the area would be 18. And for the larger triangle, one of the sides is 12 and the other side is 6. So base times height or length times width, however you want to think about it, those are going to equal 72. Okay, now before we see this, if we did this right, what should the area ratio be? Should be 1/4. All right, and then just remember from yesterday, we would take the similarity or perimeter ratio and just square both the top and the bottom. One thing people will kind of mess up on if you have a 1 on the top, if you square 1, it's 1 times 1, so that stays 1, so that should be 1/4. So if I've done this correctly, let's just check this out. If I do 18 over 72, we got to make sure that reduces to 1/4, otherwise we maybe didn't do it right. So use your calculator or do it by hand, either way. Whoops, I'm going to do it here. Yep, and it should be 1/4. So we're good to go. My similarity ratio and perimeter ratio were the same. My area ratio was the perimeter or similarity squared. So we did this correctly. Does anybody have any questions? Okay, now I told you we were going to create similar rectangles here. Come down here. I'm going to actually have you guys draw a couple rectangles, and then we'll see if we can determine if they're similar or not. So just take a couple seconds. We're going to graph these points. So just like ABCD is a rectangle, and then WXYZ is a rectangle. We're going to put them in the coordinate plane here. And if you want to, I'm going to just put the letter next to the point on mine. The first number is your left or right, that's your X value. Second number is your up or down, that's your Y value. And these should form nice rectangles when you plot them. And we're going to see if these guys are similar to each other. All right, so first thing I would maybe remind you, anytime you have a vertical and horizontal line, if they intersect each other, like in the coordinate plane here, that does form right angles. So all these guys are right angles here. Okay. And then to determine if they're similar or not, I'm going to go ahead and check to see if the sides are in proportion real quick. So in this case, this is nice because we have just nice straight lines, so we can just count boxes. So our distances, let's see, from D to C, if I'm just looking at this as an example, that goes from -7 to -1, so that distance would be 6. If I go from A to B, that would be exactly the same, that's 6. B to C, let's see, I go from -5 up to -1, so that would be a distance of 4. So the top and bottom here should be 6, the left and right should be 4 on that smaller rectangle. And the bigger rectangle, excuse me, I keep coughing. All right, let's see. From W to X, I go from 2 over to 8, so that distance would be 6. Same thing for the bottom from Y to Z. From X to Z, that goes from -2 up to 7. So that would be a distance of 9. So left side and right side of that bigger rectangle is going to be 9. Okay, now I'm just going to check this real quick. So if these are similar to each other, what side, if I pick the 4, what number would that go with in the bigger rectangle? The 6, because like one's rotated. Okay, so the smaller number in both would go together. So the 4 and the 6 would go together, and then the 6, the longer side and the smaller one, and the 9, the longer side and the larger one. Those would go together. Okay, so we're just going to check that these give us the same fraction. So 4 over 6 and 6 over 9. If they give us the same fraction, that would be our similarity ratio, which both of these guys are 2/3. And just to check to be sure, that's the similarity ratio. If these are similar to each other, what should my area ratio be? If these were similar to each other, 4/9, right? Okay, my area ratio should be 4/9. So let's just check real quick. It's easy to find area of a rectangle, right? Just base times height. So The area of this one, just 4 times 6, this would be 24. Area of this one, 9 times 6 is 54. So I'm just going to put those guys into a fraction real quick and make sure that it reduces to 4/9, just as a double check to make sure that these guys are similar. If that doesn't reduce to 4/9, then these would not be similar. So if I do 24, yep, divided by 54, and then I'm just going to convert that to a fraction real quick, and I got 4/9. So we should be okay. So this checks out as well if you wanted to find the perimeters and compare those. But as long as you got your similarity in your area, we should be good. Is anybody having a question about checking to see how they're similar? Okay. Now, the rest of this is going to be kind of piggyback on what we did yesterday. So it's going to seem similar, but I just want to practice it some more because sometimes people have a hard time with this concept. Okay, so I have a little volleyball court, that's the one on the left, and a swimming pool, that's the one on the right. And it's going to ask us to find some area, perimeter, and things like that. So let me start here. First thing I want to do is find my similarity ratio. I have one side in each of those, the one side in the volleyball court, one side in the pool, that are going to correspond to each other. And I've got 10 and 18. And that should give me my similarity ratio. But before I write the answer, I want to reduce that. So what would you write down for 10 over 18 if you reduced it? 5/9. Okay, oh good. Everybody can reduce fractions. It's awesome. What should my perimeter ratio be? Same, automatic. Okay. What about, who could raise your hand, tell me, what would you write down for your area ratio for this one? Yes, 25 over 81. Right, we're just going to square 5, that's 25, square 9, that's 81. Okay, now, they give you the perimeter of the little volleyball court here to the side, and also the area. Let's just do one thing at a time. Okay, so perimeter of the pool, unknown. I only have one side. I could get the other side, right, because it's a rectangle, so the left side and the right side would be 18, but I don't know what the top and the bottom would be. So how could I maybe use a proportion to figure out the perimeter? If I know the perimeter of the volleyball court is 60, and I know they're similar, what proportion would you set up if you're trying to find the perimeter? Perfect. 5/9, 60 over x, whatever letter you want to use. I'm going to put P on my paper because I want you to know we're doing perimeter for this proportion. I'll use A for area for the other one. But you can use any letter you want. Now, why is the 60 on the top and the variables on the bottom? Exactly. Okay. So this is smaller, right? This was a 10, this was an 8, this is smaller in the picture. So you just match that up with the smaller number. I don't know the bigger perimeter, so I match that up with the bigger number. All right, question, go ahead.
I believe I have the area from the length of the side of the yard. 60 yards.
So you could figure that out? Yeah. Would that help you figure out the side to do the perimeter in the other one? Probably. Might be faster to just use the proportion though. If you do 5 times P, that's my one cross product, and then 9 times 60 is 540. I'm just going to take 540 divided by 5 to get my answer real quick. So perimeter 108. And I do have labels in this diagram. It's in yards, so I'm going to go ahead and put yards there. Now, how would I, because I don't know the area of the pool. I do know the area of the volleyball court. How could I set up a proportion to figure out the area of the pool? Perfect, perfect. 25 over 81. So make sure, because that's the most common mistake people will make. You got to pick, if you're finding the area, use the area ratio. 25 over 81. 200, I know the smaller, the volleyball court, so I'm matching that up with a smaller number. Whatever variable you want to put on the bottom. I used A for area because we're finding the area there of the pool. And then this is going to be like a huge number. So 16,200. And then 25 times my area. And then, did anybody divide that? I think it's a nice 648. Sweet. All right. So for 648, now, if we're talking about area, and I can have a label here because it's in yards, but it's talking about square yards is what that would include. Is anybody having a question?
Oh yeah, I just figured out the little similarity ratio between the short size and the long size.
Oh.
When the size of the water one to add the both the small size together and that size bigger size.
Mm-hmm.
So that's how I got, and now I got two.
There you go. You can do that. You can do that. Okay. Now, this example is more just, almost all the problems we've already done have a picture. This does not have a picture, so you're just going to have to read through the information to pick apart what you need for this question. Okay, so it says the playing surface of two foosball tables going to be similar to each other. So ratio corresponding side lengths. If you have corresponding side lengths, that is trying to tell you you have the similarity ratio from that information. It doesn't tell you what they are, but it gives you the ratio. So it says 7 to 10. If you would prefer to write that as a fraction, that would be 7/10. That's already reduced. Okay, now the question just says from there, from that information, what would you tell me the area ratio would be between these two foosball tables? So if I know the similarity ratio, what would my area ratio be? 49 over 100, right? We're just going to square both of these. So 49 over 100, that would be my area ratio. Now, the question right under this is going to just ask us to find an area. Okay, so it says if the area of the playing surface of the larger foosball table, so the bigger foosball table, the area is being given to us, is 12.5 square feet. What is the area of the smaller foosball table? So I want to make sure, I want to use my area ratio, that one we just talked about, 49 over 100. Would you put the 12.5 on the top or the bottom of that fraction? Bottom, because it tells you the larger area, so you want to match that up with the larger number. So I'm going to find the area of the smaller one here. Now, I'm going to take 49 times 12.5, which is not a nice number, I'm pretty sure. All right, I got 612.5. My other cross product would be 100 times my area of my smaller foosball table. So I'm going to divide that by 100. And I'm just going to go ahead and fully write this out. It would be 6.125. And this would be square feet or feet squared. Since I have a label, I'll go ahead and put that in there for the smaller foosball table. Is anybody having a question? Just not giving you a picture, it's just giving you a description. Okay. I got one more and then I'll be quiet. All right, now this always throws people. So if I start out and I give you the area of two things, how can I work backwards from that to do my similarity and perimeter is what this is going to kind of ask you. Okay, so it says the area of two similar triangles are going to be 50 and 98. So I can immediately, if I have the two areas, find my area ratio. What I just want to remember is if I can, I'm just going to put those together in a fraction. I'm just going to put the smaller one on the top, larger one on the bottom. Now, before I would write that as an answer, I would just want to make sure I reduce that first. So if I had 50 over 98, anybody know what that reduces to, or could you reduce it? What'd you get? Yes, okay. Should be 25 over 49. Okay, now, that is my area ratio then, because we have the two areas. Okay, how would I, just raise your hand and tell me, how would I then find the similarity ratio or the perimeter ratio if I know the area ratio? See what you think. Do what? Square root, right? Okay, square root. Okay, so what would I put for this one? 5 over 7. I think you guys were thinking the right thing. We just want to make sure we take the square root. So you have, if you want to use the notes from yesterday, the formula was like a squared over b squared. The similarity and perimeter ratio are both a over b. So if I have this, you just take square root of 25, square root of 49, and I promise you guys will not see any problems that are not perfect squares. You might, now this question, like if you just did the 50 over 98, you're not gonna have perfect squares there, but if you reduce it, it should reduce to something that's a perfect square, so it should have a nice similarity ratio and perimeter ratio. Okay, so all that information aside, so these would be my two answers, my similarity ratio and perimeter ratio. They're both the same, they're 5/7. And then the question very bottom here, again, I don't have a picture for you. It says the perimeter of the smaller triangle is 20. What is the perimeter of the larger triangle? So how could I set up a proportion to do this last problem here? Perfect, perfect. Perfect, all right, perfect. So make sure you use the perimeter ratio, because they gave you the area, so we want to make sure we're using the correct one. So use the perimeter ratio, so 5/7, and then you know the smaller, so you match that up with the smaller number. You can use whatever variable you want, P for perimeter if that helps you. So you can get 5P, 7 times 20 is 140, and I'm pretty sure this is a nice number. It totally is. This would be 28, and I'll go ahead and, just because I had a label in the problem there, I'll go ahead and put centimeters there. Perimeter, or bless you, perimeter or side length should just be a single unit, like centimeters, inches, whatever, if you have that. Area should be squared, so like units squared, inches squared, centimeters squared. But if you're finding a perimeter, just plain centimeters there for that last question. Okay, is anybody having a question?